guys, I think you already know what's the function of the static root. And now if you have devices, how to add the static root on the devices, how to define what's the destination of the static root. If you want to know it, let's do the practice now.
Hello guys, this video we will talk something about the static routing lab guide. We already know the principle and the main command of static routing, right? And here we will use an example to show you what's the key configuration. And when we do the static routing command, what's the key point we have to know. The left also is the topology, and I add the main parameters like the IP address planning on the topology already. And the right one is the practice guide. And the background is now the customer maybe already buy some Ruijie routers, and the customer network administrator is a new employee who decide to get familiar with the principle and the basic configuration of static routing by using these devices. So, about this practice, we hope that we can master the technology principle of the static routing and also master the application scenario and configuration methods of the static routing. And here is the basic topology. And the lab requirement is now we add several loopback interfaces on the routers and to simulate the terminals. Of course, you can add some terminal on the topology. And finally, use the terminal to directly test the network connection. And now we use the loopback address. And about the route 1, we will use the loopback 1, and the IP address is 192.16.1.1/32 because this is a logic interface, so you can use a mask 32. But about the physical interface, the longest mask only can be 30. Okay, otherwise, if you use 32, the physical interface on one link, they will not within the same IP segment. And we also create 4 loopback address like loop 1, loopback 2, loopback 3, loopback 4 to make an IP address 192.168.1.1, 2.1, 3.1, 4.1. This is the IP address of the loopback address in the route 3. And the address for interconnecting between route 1, route 2, and route 2 and 3 will also have a IP segment, right? And the segment of route 1 and route 2 is 12.0.0/24. But in your real network, if on the link, especially between the network devices, you only have one link, 2 device, the mask you can change to become 30. And then the other IP address can be used for the other segment. Also, the same planning between the route 2 and route 3. But this only is a practice. If you use the mask of 24, it also can work. And we hope that we can add some static routes to implement the interconnection and interworking between loopbacks of route 1 and route 3. And the configuration IOs is the first one. We have to finish the basic configuration, includes the IP address of the loopback interface and also the physical interface. Then we have to add the static routes for each devices. Then the traffic can be finished between the different loopback interface successfully. This is the configuration process. Then let's see the detail. First, we have to complete the basic IP address of each device, right? And we can configure one by one from left to right. And also, now I already start all the devices successfully. And enter one device for the route 1. Okay, now you have to enter, enable, and because this is the first time we start, so we have to set the enable password. Ruijie R1. Of course, you don't change the host name. These devices also can work, but this one is better for us when we do the practice or on your real network. If you change the host name, maybe you can make more possible to give the suitable command in the correct device. Because if if all the devices have the same name, maybe you open all the devices at the same time, you will add the wrong configuration on the different device. So suggest to change the host name when you first time to use the devices. The command is host name. Then to create the IP address, right? The first one is the loopback address, loopback 1, and the IP address is 172.16.1.1. The mask is 32. And also enter the physical interface IP address. Oh, of course, you have to do no switch at first. No switch. Then to give an IP address 112.0.0.1, mask is 24. So this is a basic configuration of route 1, and also the same of route 2. Enable Ruijie 123, Ruijie 123. Okay, config T, and change the host. Change the host name to become Ruijie R2. And about route 2, we only have 2 physical interface. Interface gigabit 00, and no switch, and give an IP address for 12.0.0.2, 24, and enter gigabit 01, no switch, and the IP address 23.0.0.2, 24. And I suggest you finish one full configuration, please do the test. Now about the route 2, we already have 2 direct interface, right? And one is you can show your IP routing table, and to test the direct routing is correct or not. Now you will find you already have 2 direct routes, right? And another one, you can test the connection with the physical interface of route 1. On this command to ping 12.0.0.1. You also can ping successfully. That means your IP address already finished. Maybe in some scenario you add the wrong button to give a wrong IP address. So after you finish the test, you can keep that the link between R1 and R2 is successful, the IP address configuration. And another one for the route 3. Enable and config T. The host name is Ruijie R3. Yes, and also create the interface gigabit 00, no switch, IP address 23.0.0.2, 324 and create for loopback interface IP address 192.168.1.132 and loopback to IP address address 192.168.2.1 mask 32 and also loopback 3 and the IP address is 192.168.3.1 32 and also loopback 4. The IP address is 192.168.4.1 32. Now the basic IP address configuration is ready, right? And you also can see your IP routing table on Route 3. You will find we have direct routes now here, includes the loopback interface and the physical link. But now if you want to ping the test from the loopback interface of Route 1 and Route 3, you cannot ping successfully. Like the Route 3, we don't have the routing information about 172.16.1.1, right? So you cannot ping successful. If you want to finish, you can add the static route. About the Route 1, pay attention. Route 1 also same, we can check the routing information here. Show IP routing information. We only have the direct routes, one the loopback interface and another one for the physical link. And if you want to ping the 192.168.1.0, 1.1, 2.1, 3.1, or 4.1, we have to add the routing information. Now we choose the static way, right? And about the static configuration, keyword is IP route 192.168.1.1 and the mask 255, 255, 255, 255. And then the key command here, you can use a question to add maybe your next hop or maybe outer interface. You cannot directly use enter, right? For example, here we will use gateway, outer interface for the first loopback 1 of the Route 3. Enter, finish. And here is a warning. It is suggested to specify the next hop IP address when configure a non-point-to-point interface as a static routing egress. Because now your outer interface is the gigabit interface. This is Ethernet interface, not beyond to point-to-point type. So we suggest to add the outer interface and the next hop address together. At least add the next hop address. So what's the result here? Later we can check your IP routing table. And about another one, IP route 192.168.2.1 255 255 255 255 12.0.0.2. If you add the next hop, you will directly make successfully, right? There nothing warning. And of course, you can add both next hop and the outer interface at the same time. IP route 192.168.3.1. The outer interface is 00. Next hop is 2.0.0.2. And the same 192.168.4.1 255 255 255 255. 怎么会这么慢？你这里等一下剪辑的时候，如果它特别卡，那就把那个进度可以剪掉，因为我在等的这个过程当中，我都是没有说话的，这可能是服务器访问有点慢的问题，因为我们最近 VPN 用的人太多了。Enter. And this is a basic configuration of the route 1. And now you can use the command show IP routing table and enter. You will see four static routes, right? But the special one for the loopback 1 interface of R3. You will find that if you don't add the next hop, the routing information will think the code still is S, but the destination 192.168.1.1/32 is a directly connected route because you don't tell them what is your next hop. So this is the mistake if you don't add the next hop address. And then this is a basic configuration of the R1. And let's say the R2. If now PC1 send out the message 172.168.1.1, this is the source IP address, and the destination IP address is 192.168.1.1. So about the route 2, I will receive the message. The destination is 192.168.1.1, right? But when we receive this message, you can see the IP routing table on route 2. I don't have any information about the 192 segment, so we have to add this IP routing information in order to forward the message to the destination 192 successfully. And here, about the route 2, first you have to add the command IP route and destination 192.168.1.1. 255.255.255.255, and the out interface is 1 gigabit 0 gigabit 1 23.0.0.3, right? Also same, you can directly use the up button and change the destination to become 2 because they have the same out interface and the next hop. And also change the next destination to become 3, and also the 4. Yes, so if route 2 now receives a message to visit the destination 192 segment, we already have the IP routing table, right? Show IP routing table you can find, but pay attention please. The communication successfully, that means route 1 sends a message to route 3, and route 3 can give a reply. So, when the reply about the message, the source IP maybe is 192.168.1.1. The destination IP will become 172.16.1.1. And when route 2 receives this message from route 3, route 2 also needs the destination information and then to forward to route 1. But now on the routing table, we don't have any segment information about 172, right? So here we also need to add this segment back to route 1. 172.16.1.1, 255, 255, 255, 255. Okay, and please give the correct out interface and the next hop. Interface is 0012.0.0.1. Okay, so now you can show your IP routing table again. You will find that we have already the routing information come back to route 1. So this is the basic configuration of route 2. And about the route 3, the routing table is very easy, right? Because we only add one route information, it's enough. The destination is 172.16.1.1, 255, 255, 255, 255. and the outer interface is 00. Next hop is 23.0.0.2. Okay, now the basic configuration is ready, and we can test the result. The result tracking. The first one, you have to check your routing table is full or not. We already do after we add the command and directly check the result, right? Show IP routing table. On the route 3, we can see the static route to wait the R1. So the routing table is ready, and now we can test the network connection. And about the test, if you do the test on the router, please know it. First, about the ping only can be finished on this configuration page. And the command is ping 192.168.1.1. This is the address of route 3 loopback interface, right? And pay attention, someone may be directly ping, and you will find the result is not suitable, right? So why the ping is cannot successfully? Because about route 1, if you directly ping the destination, route 1 have two interfaces. One is physical interface, one is a logical interface. About route 1, we will directly to choose the physical interface that closest with the destination. This is the address of the gigabit 00, 12.0.0.1. But when we do the configuration, we only add the static route about the loopback interface, not about the physical link. So if now route 1 send out the message, the source IP address is 12.0.0.1, destination is 192.168.168.1.1. This message can be sent to route 2. Route 2, according to the destination IP address 192, and we can match the static route on the routing table. It also can be sent to route 3. But when route 3 replies the message, now the destination IP address will become 12.0.0.1. But on route 3, we don't have this routing information, right? Includes the 12.0.0. So the message cannot reply. The result is connection is broken. So if you do the test on this scenario, you must to let route 1 know we have to use your loopback interface as the source IP. So the ping on the route 1 also ping 192.168.1.1, and please choose the source to become 172.16.1.1. And you will find the ping successfully, right? And also, if you want to ping another address, another loopback interface of route 3, 2, also can successfully. 3, it also is working, and 4, it's working also. So this is a key point when you do the testing on your topology. Of course, if you add some terminal two pieces on this topology and give the correct IP address and the correct gateway mask on the terminal, then you can directly on your terminal ping to the destination 192.168.1.1. It can work. So pay attention about the test result. So in this process, when we do the static route configuration, the key point of the lab is when you do the IP route static, you can add the destination, you can add the mask, and the key point is you can add the next hop, you can add the outer interface, you can add both of them. So what's the difference? Now, according to the result, we will find all the destination can be tested successfully, right? Although maybe when we add the static route on the route 1, we only add the outer interface, not add the next hop. But in the whole process, there is an explanation. If you only add the outer interface, we will do more process to get the next hop. So, if only the next hop address is config, a static route will be displayed in the routing table successfully, and the administrative distance is 1, right? We can show the IP routing table on route 1. You will find if we only have the next hop address, you will find something like this. This is a static, and the administrative distance is 1, and the cost value is 0. And the no information about the outbound interface is displayed. If a packet matches this route, for example, now we want to ping the destination is 192.168.2.1, the device performs the next step and find out the outbound interface for sending out the packets. We will take the next hop and then to match the routing table again to find the outer interface. Because we finally, after we finish encapsulate the message, we need one interface to send out, right? So in this experiment, the 12.0.02 matches the root of 12.0.0/24, and the outer interface is gigabit 00. This method we call is root interactive query. If only we have the local outbound interface is config, like this route, right? Like this route, we only add the outer interface. And when we use the command to check, we will find this will be displayed like the directed connected route. After the configuration, there is a warning to show you, please suggest to add the next hop address. If this interface is a point-to-point interface, it doesn't matter. But we will find after we see this suggestion and do nothing, right? We don't add any more configuration here, but this routing information still can work. So here is a suggestion for you. When you do the static configuration here, please add both local outer interface and next hop address at the same time, like these two routes on the route 1, right? And this is the full correctly show on the static route. So this is a key point when you do the static route on the route 1 and route 2 and route 3. And another one, in this topology, the special places is about route 1, we now add 4 static routes to wait for rollback address of route 3, right? And the characteristic of these 4 static routes is all of them we will use the same outer interface and also the same next hop. So we can use a special one route to wait the destination. The special one we call is default route. And default routes are a special type of static routes, and pay attention about this one. Default routes can be configured by static way, and also we can use some special dynamic protocol to transfer the static route, to transfer the default route. So pay attention about this part. Not means default route must be static route, must be static type. So in this practice, we also can use one default route to indicate 4 static routes of the route 3. So about route 1, you can delete the 4 static routes at first. No IP route 192.168.1.1 255. Okay, you can delete at first, and also 2, and also 3, and also 4, right? And now on your IP routing table, you will find you only have 3 direct routes. And exist, now you want to ping the destination and use the source 172.16.101. You cannot ping successfully because you don't have the routing information. But here, you can add a default route to indicate 4 static routes of route 3. Config T and IP route 000 000 and the outer interface is gigabit 0012.0.0.1. IP route 000 gigabit 12. Oh, this 0.1, this address is wrong, right? This is IP address of route 1, so the address should be 2. This one is correct. So if you don't add the command successfully, it doesn't matter. Only check the warning notification and you can get the correct command. And then you can show the IP routing table here. You can see the static route, right? And then you can test the result. To ping again, for the destination is 192.168.101 and the source is another one. You will find the result is successful. And although maybe you want to ping the destination of 2.1 can successfully, and also the 3.1 can be successfully, and also the 4.1. Also can successful, right? 什么鬼啊? So now on route 1, we only add the default route, but we can indicate for destination and also can wait successfully. So this is a function of the default route. Of course, if above route 1, you have multiple outer interface to wait the destination. In this scenario, the default route is not suggested. Only you have one outer interface and a special, that means you have lots of destination you want to wait, and the next hop and outer interface are same. In this scenario, you can use a default route to indicate multiple destination. So that's all about the static routing lab guide. Thank you.